What is cholesterol? Cholesterol is a waxy, fat-like substance that found in all cells in the body, and it comes from two sources, which the foods you eat and your liver. Our body needs some cholesterol to make hormones, vitamin D, and substances that help you digest foods. Types of cholesterol and what to do. First, high-density lipoprotein or HDL. It brings cholesterol from cells to liver. Liver then break it down or passes it out of the body as waste product. HDL is known to be good cholesterol that is useful to the body. Second, low-density lipoprotein or LDL. It brings cholesterol from liver to cells. Excessive usage of cholesterol by cells can build up in the arteries and cause health problems. LDL is a bad cholesterol that can harm body. Healthy level of cholesterol in the body. High-density lipoprotein should be 40 mg per deciliter or higher, while low-density lipoprotein should be less than 100 mg per deciliter. If the level of cholesterol is high in the body, it can lead to memory loss, stroke, heart disease plus angina, heart attack, lower blood flow, gallstone plus abdominal pain, diabetes, and cramps. After the brief explanation of cholesterol, let's move to the catabolism of cholesterol. What is catabolism of cholesterol? In this process, the chief metabolic end products are bile acids, vitamin D, and may also be converted into steroid hormones. Catabolism of cholesterol also does not produce energy and the structure remains intact. Next, bile salt. Bile salt is produced in the liver and secreted to bile duct and gallbladder. It's helped to absorb and digest the fats and fat-soluble vitamin. Through oxidation, cholesterol is excreted and synthesized into various types of bile acids. The next end product is vitamin D. Cholesterol is the precursor for vitamin D synthesis. It is linked to cholesterol as we need cholesterol in skin cell to make vitamin D from sunlight. Cholesterol, which present in the form of 7-dehydrocholesterol, will be converted to vitamin D3 by UV rays. The last end product of is steroid hormone. Cholesterol is the precursor of the 5 major classes of steroid hormones, which are glucocorticoids, mineralocorticoids, progestins, androgens, and estrogens. These hormones act as signal molecules that regulate a host of organisms' functions. Now, let's take a look at the pathway involved in the end product. First, let's take a look at synthesis of bile salt from cholesterol. First, cholesterol is being converted into 7-hydroxycholesterol by the 7-A hydroxylase enzyme. Then it will be converted into cholic acids and chenodeoxycholic acids. With the conjugation of glycine and taurine, the conjugated bile acid or primary bile acids, glycoylate and taurochylate were formed. Furthermore, same with chenodeoxycholic acid, the conjugation formed primary bile acids, namely glycosenodeoxycholate and taurochenodeoxycholate are formed. Through deconjugation and dehydroxylation, these primary bile acids are converted into deoxycholic acid and lithocholic acids, which are known as the secondary bile acids. Next, let's move to the importance of primary bile acids. Firstly, it helps emulsification and digestion of lipids. Next, for absorption of fat-soluble vitamin, and lastly for solubility of cholesterol. As additional info, approximately 95% of the bile acids are reabsorbed from the intestines, and the remainder are lost in the feces. Next, let's move to synthesis of vitamin D. When our skin is exposed to sunlight, it makes vitamin D from the cholesterol. As we know, cholesterol degradation is also the precursor for vitamin D synthesis. In vitamin D synthesis, cholesterol which is present in the form of 7-dehydrocholesterol is converted to cholecalciferol which is vitamin D3 by UV. The hydroxylation reactions occur in the liver mediated by the 25-hydroxylase, convert the cholecalciferol into 25-hydroxycholecalciferol. Next reaction takes place in the kidney, mediated by 1-alpha-hydroxylase which converts 25-hydroxycholecalciferol to the calcitriol. Next, let's move on to the function of calcitriol. Calcitriol is a form of vitamin D3. Vitamin D helps your body absorb calcium from the stomach.
5, 4, 3, 2, 1.